The moment the sun finally shifted out of the way, the James Webb Space Telescope locked onto something no one had been prepared to see, and the quiet equilibrium of the astronomy world shattered. The interstellar object, known as 3I Atlas, had returned, but it was no longer the faint, drifting visitor it had once appeared to be. This time, it blazed at more than 4 times its previous brightness, as if an internal engine had awakened and flooded its surface with impossible light. Webb recorded a glow that refused to behave like dust, gas, or ice. Instead of scattering randomly, the light traveled in smooth, controlled waves across the object's exterior, almost as if the surface itself were adjusting to the heat pouring from the sun. And when astronomers finally sharpened the images, a new shape emerged beneath the shimmering exterior. Perfectly aligned metallic hexagons forming a geometric grid too clean and too precise for anything shaped by natural forces drifting through the cold wilderness of interstellar space. Before anyone could fully process the meaning of that discovery, another anomaly appeared, a faint ultraviolet flash pulsing every 247 seconds with clockwork precision. The timing felt closer to a deliberate transmission than any natural cycle. None of it matched a comet's profile. None of it resembled anything humanity had ever seen, prompting an unsettling question to rise through every discussion, every late-night call between observatories, every urgent email sent across scientific networks. If 3I Atlas had returned brighter, sharper, and more controlled than ever before, then why had it come back at all? Long before its reappearance, the object's journey had already carved its name into the short but enigmatic history of interstellar visitors. Only 2 confirmed interstellar objects had entered our solar system before it. The first was Oumuamua in 2017, that bizarre cigar-shaped traveler that still sparks arguments among scientists. The second was Comet Borisov in 2019, a more traditional comet that simply passed through and vanished. When 3I Atlas arrived, it became the 3rd visitor humanity had ever documented from beyond our stellar neighborhood, and that alone was enough to turn every major observatory toward it. Even in the months before its disappearance behind the sun, something about the object had unnerved astronomers. Hubble watched it. KK in Hawaii tracked it. Observatories across Europe and the Americas recorded its movements each night. This level of coordination was unusual. Astronomers do not track comets this obsessively unless something about them feels distinctly off. And with 3I Atlas, that feeling emerged almost immediately. Its orbit refused to behave like a natural comet's. Its brightness shifted in ways no model could explain. Even when teams compared notes, the data resisted all attempts to fit it into familiar patterns. Instead of tracing the graceful arcs of long-period comets drifting in from the Oort cloud, 3I Atlas followed a sharper, less predictable path, as though responding to forces not found in textbooks. Some nights the light curve dipped too deeply, others it brightened too quickly, and every attempt to fit the readings into conventional equations produced more confusion than clarity. Yet astronomers kept watching because once something arrives from another star system, the last thing you do is look away. Then, just as the data began hinting at a deeper mystery, 3I Atlas slipped behind the sun. With no way to see through the solar glare, the world's telescopes could only wait. Weeks passed without updates. Months even. But the anticipation didn't fade. Instead, it grew heavier, more electric. Everyone sensed that when the sun finally revealed the object again, what emerged would not be ordinary. That intuition proved correct. When 3I Atlas returned to view, the very first readings blindsided every team monitoring it. The object's brightness had spiked more than 400%, far too dramatic to blame on dust shedding or fresh ice exposure. Comets do brighten when heated, but they do not transform into cosmic mirrors. The James Webb data suggested that the surface had been polished or reconfigured during the months it remained hidden. Stranger still, its surface temperature held steady, refusing to heat up or cool down the way natural bodies do as they travel through the solar system. It behaved like a system actively managing its own heat, maintaining a controlled range regardless of solar exposure. As scientists examined the smooth rises and falls in its brightness, the pattern resembled something deliberate, like adjustable panels shifting to balance illumination. Telescopes around the world scrambled to find natural explanations, but nothing fit. Dust jets don't move evenly. Ice vents don't stabilize temperature. No comet keeps its heat constant while displaying such dramatic reflectivity changes. And beneath the reflective glow, glimpses of rigid shapes appeared, as those segmented plates shifted in unison. The comparisons to heat-regulating satellite panels emerged almost immediately, and though no one dared claim confirmation, the possibility was enough to unsettle the most seasoned researchers. Piece by piece, the object began to look less like something shaped by nature and more like something designed. Any remaining doubts cracked when the tail reversed direction. Natural comets form tails that always point away from the sun due to radiation pressure. But 3I Atlas produced a clean, narrow anti-tail aimed directly at the sun, the one direction a comet's tail should never go. Hubble confirmed it. KK confirmed it. Multiple European telescopes confirmed it. The anti-tail did not waver or drift. It held a steady line as though guided by an internal force. Natural jets don't behave that way. They scatter. They erupt irregularly. They don't lock into precise orientation and tighten with each rotation. This plume looked anchored, almost like the thrust from a propulsion system. And then came the spectral readings. Instead of the usual chaotic blend of rock, dust, and ice, the spectrum was dominated by refined nickel-iron alloy, far too pure for natural formation. Cyanide compounds appeared too, in structured distribution rather than random, clinging debris. The light curve suggested a hollow interior, as if illumination was passing through chambers. Even its calculated mass was far too low for its size. The numbers pointed again and again toward a hollow shell, a constructed exterior, an engineered object. Then a small observatory in Spain captured a sequence of 159 consecutive images that changed everything. A narrow jet extended from the object in a perfectly steady beam. Not a plume, not a burst, but a needle-thin emission that stayed aligned across all frames, maintaining a constant shape even as the object rotated. Natural jets brighten and fade with angle. This one didn't. It looked controlled, purposeful, and every time it fired, 3I Atlas shifted course slightly. Smooth corrections reminiscent of how spacecraft perform minor adjustments. The idea that the object might be steering itself, quietly, deliberately, spread through the scientific community like a hushed warning. When the object slipped behind the sun, the world expected partial interference or reduced visibility. What no one expected was absolute silence. Not a glimmer, not a photon, not a trace. It was a complete blackout, something telescopes had never observed from an interstellar object. Weeks passed with nothing but void where the object should have been. Some suggested it had dimmed. Others wondered if the reflective layer had collapsed. But none of those explanations aligned with the earlier brightness spike or the controlled jet activity. Whatever happened behind the sun seemed intentional, hidden by design. And when 3I Atlas reemerged, it was different. The brightness pattern had changed. The structure beneath the surface looked more defined. The jets appeared stronger, firing in new patterns. It was unmistakably altered. Something had happened during the blackout, something we were not meant to witness. But the most astonishing moment came when the object began emitting ultraviolet flashes every 247 seconds, precise to the millisecond. Natural objects do not keep time. These flashes mapped directly onto a sequence of prime numbers, 2, 3, 5, 7, 11, and onward. Then came a 13-minute, 37-second UV emission that, when converted to data, formed a spiral aligned with the golden ratio. Embedded within the spiral were repeating binary markers, intentional, structured, message-like. SETI researchers instantly recognized the implications. Prime numbers and golden ratio spirals are not natural signals. They are signatures civilizations might use to communicate across the cosmos. Quiet debates erupted behind closed doors. Was this a mathematical greeting, an encoded instruction, or something else entirely? Before anyone could determine an answer, 3i Atlas made one final move. Its trajectory shifted just 0.09 degrees, but undeniably real. Then its speed increased along a smooth acceleration curve impossible for a natural object. It was leaving, not drifting, departing, as though it had accomplished whatever mission brought it here, as though it had revealed exactly as much as it intended, no more, no less. And then it vanished back into the dark between stars. So the final question remains, hanging over everything like a whisper in the void. Did we simply witness an unusually strange comet, or did we watch the quiet arrival and departure of a constructed device built by another civilization, passing silently through our solar system to observe, to measure, perhaps even to communicate? Whatever 3i Atlas truly was, it behaved in ways no natural object ever has, and its visit leaves humanity with a mystery that stretches far beyond science. What do you think it really was?